In today's video, here is a nice improper integral. It sets as I from 0 to plus infinity of sine of x squared dx. Okay, this is very famous integral. Is called fresnel integrals. So as we evaluate the sine of x squared, it will be the same thing for us cosine x squared. Okay, so now let's get started with this one to see what's given us. Based on the Euler formula, we know e to the I x squared equals cosine of x squared plus I sine x squared. Okay, we know this imaginary part, which is this integral from 0 to plus infinity of sine x squared dx, equal the imaginary of integral from 0 to plus infinity of e to the I x squared dx. Okay, so I'm going through the substitution. Let's set e x squared equals minus z squared. Okay, we know minus 1 equals I squared, so I'm going to replace minus number 1 with I squared. We are going to ignore the negative sign because we are dealing with integral from 0 to plus infinity. So get square root of I x equals I z. Okay, so I get x equals I over square root of I z, which equals I over square root of I, which is the same as square root of I z. Okay, let's differentiate this one. So I get dx equals square root of I dz. So I have ended with this nice expression. I'm going to change x into z. So I get here I integral imaginary from 0 to plus, so the bounds will be the same. So I get e to the I x will be replaced with minus z squared, dx will be replaced with square root of I dz. Okay, so by taking square root of I out of this integral because it's considered as a constant, so I get I equals imaginary square root of I from integral from 0 to plus infinity of e to the minus z squared dz. Okay, now at this moment we are going to evaluate this one, imaginary of square root of I. So we know square root of I equals a plus ib, like this. I'm going to square both sides. I will be ended with a square here plus 2 ieb minus b square, because I square equals minus number 1. Okay, this one equals I. I'm going to do like terms. We get a square minus b square equals 0. Also I get 2 ab equals 1. Okay, so I get here a square equals b square. Just square on both sides. I get 4a square b square equals 1. Replacing b square with a square, I get here b square with a square. I get 4 a to the fourth equals 1. I get e to the fourth equals 1 over 4. Okay, so I get e square equals 1 over 2. So I'm taking only the plus sign because I'm dealing with positive sign. I'm going to deal only the positive terms, where only the negative. I'm going to ignore the negative terms here. So this one is given as a plus square root of 2 over 2. So as I said before, imaginary of square root of I, imaginary a will be replaced with square root of 2 over 2 plus a square root of 2 over 2. Okay, the imaginary of this one equals this one. I'm taking square root of 2 over 2. Now the I integral equals this one, square root of 2 over 2 is multiplied by integral from 0 to plus infinity of minus z squared dz. So this is very famous integral, is a Gaussian integral. I'm not going to prove it now. I let you guys, you can prove this one and let me know in the comment section below. So this one is square root of 2 over 2. So this one equals square root of pi over 2. Okay, because we know this one from minus infinity to plus infinity equals square root of pi. Okay, so since this function is an even function, I'm going to take only the half of this integral, so we can prove it by polar coordinate. You put in the unit circle and change this integral into two variables, x and y, by putting x equals r cosine theta y equals r sine theta, and change the Cartesian coordinate into the polar coordinate, you will find the results quickly. Okay, this is the value of this integral. I'm going to put this one inside. It's giving us square root of 2 pi over 4. Okay, so I have undo this video. By the way, don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.